Section 1.5 is on more identities. So yesterday we talked about how tangent of theta is equal to sine over cosine. And we also talked about the Pythagorean identity with sine squared theta plus cosine squared theta equals 1. So those are the most important ones from yesterday that we talked about. So today we're going to be talking about how to simplify different trig functions by using identities. So the first example we're going to do is we're going to write tangent theta in terms of sine theta. So that means in terms of we need sine to be the only trig function that shows up in this ratio or in this problem. So let's start with what we know. We know tangent of theta is equal to sine theta over cosine theta. Now we need to figure out how to replace cosine theta so it's in terms of sine. So if we look, the only one that has both sine and cosine would be our Pythagorean identity. So we have sine squared theta plus cosine squared theta equals 1. We need to get cosine by itself. So we're going to start by subtracting sine squared on both sides. And then we would have cosine squared theta equals 1 minus sine squared theta. Then we're going to take the square root. So we know that we have cosine theta equals plus or minus the square root of 1 minus sine squared. This is on one of our trig identities sheets from yesterday, but you'll notice if you don't have it memorized, you can find it by just having the Pythagorean identity memorized. So then our final answer we can leave as sine theta over plus or minus 1 minus sine squared theta. And that would be our answer. And that's how we could write tangent in terms of sine. Most of them aren't going to be that complicated, the ones that we are going to be doing. Our next example, we are going to write secant theta, tangent theta in terms of sine and cosine, and then we're going to simplify. So we're going to start with the statement they give us, and you should always start with this so that you don't end up making a mistake or replacing something that you shouldn't. Then we're going to turn everything into sine and cosine. So secant we know is 1 over cosine theta. And we know tangent is sine over cosine. So I'm going to put sine theta over cosine theta. And then we have a fraction times a fraction. So we're just going to multiply straight across. And we're going to have sine theta over cosine squared theta. Anytime you have a function that is squared, you are going to be able to simplify further. So we're going to continue on to our next one. And if we look back at our two most important identities, the only one that we see cosine squared in is in our Pythagorean identity. So if we have sine squared plus cosine squared equals 1, we need to figure out what just cosine equals. So we need to get that by itself. To do that, we're just going to subtract sine squared on both sides. And then we would be left with cosine squared theta equals 1 minus sine squared theta. So our simplified answer is going to be sine theta over 1 minus sine squared theta. If we were to be able to factor here, then we would, but in this case, we can't. So that would be our final answer. Our next example, we are going to be adding, and when you add fractions, you need a common denominator. So for this one, we start with 1 over sine theta plus 1 over cosine theta. So we are going to get a common denominator, and the easiest way to do that is to multiply by the opposite denominator. So if we do that, we're going to end up with cosine theta over sine theta cosine theta plus sine theta over cosine theta. Oh, sorry. I want to write them in the same order. So I'm going to start with sine theta times cosine theta. Now that we have a common denominator, we can go ahead and just add these two fractions together. So we're going to have cosine theta plus sine theta over sine theta cosine theta. If there were any common factors between the numerator and denominator, we would be able to simplify further. But in this case, because there's that addition sign on top, this is going to be our final answer. Our next example, we are going to be multiplying. And when you multiply with parentheses like this, don't forget that you are going to FOIL your work. So we're going to start with sine times sine, which is sine squared theta. Then we'll move on to sine times -5. And 2 times sine. And because those are both positive, we're going to do plus 2 sine. And lastly, 2 times -5 is minus 10. Once you get to this point, you can combine any like terms. Minus 5 sine plus 2 sine is the same thing as having -5x plus 2x. So we treat them just like we would treat variables. So we're going to keep our sine squared theta. We haven't done anything with that. And then our middle two terms are going to combine to be minus 3 sine. And we're going to keep the minus 10 at the end. And once you've done that and combined your like terms, you're going to have your final answer. Our next example, we're going to show that the following statement is true by transforming the left side into the right side. So you're always going to start by rewriting the left side. So we're going to start with cosine theta tangent of theta. And then you're going to write everything in terms of sine and cosine. So if anything isn't in sine and cosine, you are going to change that. So in this one, we're going to change tangent to sine theta over cosine theta. Then once you do that, you are going to simplify when possible. So in this one, we are going to end up multiplying these two together. And because it's a whole number times a fraction, you put the whole number over 1. And then you just multiply straight across. So we would get cosine theta, sine theta on top, all over cosine. And we are multiplying on top, so it is okay to cancel out or simplify any common factors between the top and the bottom, the numerator and denominator, which will leave us with just sine theta. So that was the goal of what we were trying to show. On a quiz or a test, you do have to show all of these steps. So it's kind of like a algebraic proof where you're showing everything that you've done. If you just wrote down cosine theta times tangent theta equals sine theta without showing the steps of why, then you wouldn't get full credit for this type of problem. So make sure you're showing the steps as to why you got the answer you did. Okay. Lastly, or next, we're going to prove the identity of sine theta plus cosine theta squared equals 1 plus 2 sine theta cosine theta. So to do that, you are going to choose one side of the equations and you're going to work with that. So for this one, let's choose the left side of the equation. We have sine theta plus cosine theta in parentheses squared. So the first thing we're going to do is we're going to work with that squared. So remember, that means you're taking it multiplied by itself, so we are going to have to FOIL this. And if we FOIL, we're going to end up with sine squared theta plus sine cosine plus another sine cosine, and lastly, plus a cosine squared. Then you're going to want to combine any like terms and see if there's any parts that you want to put together for an identity. So I noticed we have both a sine and a cosine squared, so I'm going to put those together because I know that that is part of a Pythagorean identity. And then we can also combine, we have a sine cosine, we have two of those, so we can have plus 2 sine theta cosine theta. Because we know sine squared plus cosine squared equals 1, we can now substitute 1 in for this part of the equation. So we're going to have 1 plus 2 sine theta cosine theta. And that was what we were trying to prove, so that is the end of our problem. So knowing those identities is important for these types of problems because you're going to be substituting in them for each other all the time for this. All right. Next, we're going to simplify the expression, the square root of x squared plus 9, as much as possible after substituting in 3 tangent theta for x. So we're going to take this, and instead of x, we're going to plug in 3 tan of theta. So if we plug that in, we're going to have 3 tangent theta squared plus 9. When you have something in parentheses, that means you have to square both parts. So we're going to have 3 squared, which is 9, and then we're going to have tangent squared theta. And don't forget, we still have that plus 9 at the end. So if you look at this, you'll notice we'll be able to factor out a 9, and we'll have tangent squared theta plus 1. Now, if you don't have the tangent squared Pythagorean identity memorized, that's okay. We can still get it from the Pythagorean identity of cosine squared theta plus sine squared theta equals 1. We know tangent is sine over cosine. So we have a sine here that we can divide by cosine squared to get tangent squared. If we divide that by cosine, we're also going to divide the rest of the equation by cosine as well. So then we know this simplifies to 1 plus sine squared over cosine squared would be tangent squared. And 1 over cosine squared is secant squared. So by taking that Pythagorean identity and dividing by cosine squared, we found a second Pythagorean identity. And you'll notice 1 plus tangent squared is exactly what we have inside of our parentheses here. So we can substitute that in. So we're going to have the square root of 9, and in for tangent plus 1, we're going to plug in secant squared. Then we can take the square root of both parts. So we can take the square root of 9, which is 3, and the square root of secant squared, which is just secant theta. And that is the last example. I decided to change the homework problem because this is a Wednesday assignment. So we're just going to do these 10 problems, and for these, you're going to be able to follow some pretty basic steps. So the first thing you're going to do, again, is write down your equation or expression. And then you are going to change everything to sine and cosine. And then you are going to simplify. I challenge you to do these without using your formula sheet or without looking back at your notes for the identities, because that way you'll prepare yourself for the test that is coming up this Friday. If you have any questions, let me know. And I will have the answer key posted. Just know the answer key is going to have all of the original problems on there as well. So make sure you're going to the correct problem when you check your answers. Let me know if you have any questions.